We want to find the average value of the function f of x equals 3 cosine 2x over the closed interval from negative pi divided by 6 to pi divided by 3. The average value formula is shown below as f sub average, which equals 1 divided by the difference of b and a times the integral from a to b of f of x dx, where in our case, a is negative pi divided by 6 and b is pi divided by 3. This indicates the average value of the given function over the given interval is equal to 1 divided by the difference of pi divided by 3 and negative pi divided by 6 times the integral from negative pi divided by 6 to pi divided by 3 of 3 cosine 2x dx. Let's simplify pi divided by 3 minus negative pi divided by 6. Multiplying pi divided by 3 by 2 divided by 2, we have 2 pi divided by 6 plus 1 pi divided by 6, which is 3 pi divided by 6, or simply pi divided by 2. This gives us 1 divided by pi divided by 2. And now we have to perform U-substitution to integrate, where u is equal to 2x. So if we have u equals 2x, du equals the derivative of 2x with respect to x times dx, or 2 times dx. Notice we don't have 2 dx, we do have 3 dx. Let's go ahead and leave the 3 there, and let's go ahead and solve this for dx by dividing both sides by 2. This indicates that 1/2 du equals dx. And now let's write the integral with respect to u. We need to be careful. The limits of integration, negative pi divided by 6 to pi divided by 3, are x values, not u values. So we'll leave the limits off for now. 2x equals u, giving us cosine u. And then dx equals 1/2 du. And we still have this factor of 3. And therefore we have 3 divided by 2 times cosine u du. And now let's find the new limits of integration with respect to u, where u equals 2 times x, which indicates when x equals negative pi divided by 6, u equals 2 times negative pi divided by 6, or negative pi divided by 3. And when x equals pi divided by 3, u is 2 times pi divided by 3, or 2 pi divided by 3, or 2/3 pi. Let's go ahead and simplify one more time. 1 divided by pi divided by 2 is equal to 2 divided by pi. Let's go ahead and factor out the 3/2. For the next step, let's simplify 2 divided by pi times 3/2. 2 divided by 2 simplifies to 1, leaving us with 3 divided by pi. The integral of cosine u is equal to sine u. So the antiderivative is sine u. And now we evaluate the antiderivative at the limits of integration. We have 3 divided by pi times sine of 2 pi divided by 3 minus sine of negative pi divided by 3. And now we need to find these trig function values, either using the unit circle or reference triangles. I'm going to go ahead and use the unit circle. Recall in the unit circle, y is equal to sine theta. This indicates sine of 2 pi divided by 3 is equal to square root 3 divided by 2. And negative pi divided by 3 is coterminal with 5 pi divided by 3, which indicates sine at negative pi divided by 3 is equal to negative square root 3 divided by 2. Going back to our work, we now have 3 divided by pi times square root 3 divided by 2 minus negative square root 3 divided by 2, which simplifies to square root 3 divided by 2 plus square root 3 divided by 2. We now have 3 divided by pi times 2 square root 3 divided by 2. And of course, 2 divided by 2 simplifies to 1. The exact average value is equal to 3 square root 3 divided by pi. And now let's briefly talk about an interpretation of this value. If we were to sketch a rectangle over the same interval where the height of the rectangle is equal to the average function value, which is this red line, the area of this red rectangle over the interval, this area here, is equal to the value of the depth integral of the given function over the same interval. So the area of this rectangle is equal to the value of the depth integral over the same interval. And because this function drops below the x-axis, we can think of this as signed area, where the area above the x-axis would be positive, this area here. And the small area on the right would be negative because it's below the x-axis. And if we sum these two signed areas, again, it would equal the area of the rectangle formed using the rectangle with a height of the average function value. I hope you found this helpful.